So shall we start the session? Okay.
Madam, started.
Yes, yes,
Okay.
ma'am.
Okay, thank you. Okay, so this is me Amrita again. So good morning to the Bharata students. So today I shall solve some problems in week 3. So I will share my screen. So are you able to see the screen in the peer link? So I would like to ask you to join this peer link session. So you go to this joinpd.com and type in the code so that you will get the presentation in your end. So once you have enrolled, we can start the session. Students, please use this website ID and then this code to join the question session. Okay. So one student has connected. So once you all join, now we shall start the session. Okay. So in my space live session, we saw how to deal with this fundamental subspaces and some projection matrices and some least square method. So today we will get hands-on on yes. Hello, is anybody interrupting? All of you joined this session. So I have posted the first problem here. So are you able to see the problem in your side? So this is the question. So for a matrix, consider any matrix. So of size m cross n. So with n greater than m, so there can be n pivots. So this is a statement. You have to identify whether it is a true statement or false statement. Give it a, so let me give you 2 minutes to think on it, and we'll see the answer based on your responses. Okay. So one of you are given a false. Any more responses? Okay, 2 of them are given. 2 people have responded. So, okay, so let's see the answer. So it is false. Okay. So why? Because your matrix has m rows and n columns. So any matrix has the pivot entry in the column element. So if you have m rows, then if the number of columns is greater than your number of rows, it means you cannot have more than m number of pivots. So in the question we had n is greater than m, so there cannot be n pivots. So your answers are correct. It is false. So this is your next question. So what will be the column spaces of these particular matrices? So the matrix A I am given here. It has two columns with 1 0 0 as the first column and 2 0 0 as second column. And matrix B with 1 0 0 as the first column. The second column is 0 2 0. So you have to match which column space is of which nature. So these are the options. So you have to choose which is the correct option. So I'll give you 2 minutes. I just you can also work on it or you can think about it. So what will be the nature of the column space? Will it be a line or will it be a plane? Okay, I got one response. So let me get the responses. Two of them have responded. Okay. Okay, I'm getting responses. So four of you have responded. So let us see. So if you can, so you can see my screen. So let us see your responses. Okay. So one of you are given both the lines, and three of you are given that C of A is a line and C of B is a plane. Okay. So actually the option 2 is correct. For the matrix A, the C of A has only X element in both the columns. So which when you draw it, it will get a line. But wherein for your matrix B, you have two columns. So two columns both are independent. So they form a plane. So that is the answer. So this is your solution. So for the matrix A, we have C in the C of A. If you find so this column 1 and this is column 2. Column 2 is dependent on column 1. So this column space is simply the column vector that is 1 comma 0 comma 0. So if you draw the column space, it is simply a line, and the second column is a point along this line. And for the second matrix B, so here these two are independent columns. So we get two different points which forms a plane. So that is how we describe the column space of a given matrix. Let's move on to the next question. So find the null spaces of these three matrices A, B, C. So this is your A matrix. So it consists of two rows, and this B matrix and C matrix was formed from the CA matrix. So you form this first. If I have to give your answers like you mark A and then write the null space value. You might get a point or vector or anything. So A and write the answer, and comma B and you write the answer, comma C and you write your answer. So I'll give you some 2 more minutes, 5 minutes to solve for the problem. So I hope you are working it out. Okay, none of you have responded. Three responses. So, okay, so we got four of your responses. So let us check your responses and then we'll discuss on the question. So one of your so you're still responding. I'll give you some 2 more minutes. You can solve for it. We have already shown yesterday in an essay session. We saw how we form the null space of a matrix. This is a simple 2 x 2 matrix. You will get some interesting idea insights if you solve this null space for the matrix. Okay, so we have got the answers. So let us see someone okay, still typing. Okay, let him type. So once you finish your typing, then I'll give you the answer. Meanwhile, you can think about the nature of the columns of these two matrices, how they will be. So shall we see the response? Okay. Okay. So we got some 4 answers. So let us discuss on the answers. So the first answer, what is no null vectors in A? Okay, that sounds to be a good answer because for the matrix A, we do not have any. We'll see the solution. Okay, then this is also correct. And 0, 0, comma, minus 2, comma, 1. Okay, minus these two answers are correct. 0, but the third one, this is incorrect. We will see. And 0, 0, minus 2, comma, 1. Okay. Oh, someone is still typing. Okay. So shall we see the answers? We want some more time to think on it. Okay. So we shall see how it works. See, there are. So let me share my another screen. So are you able to? I hope the screen is visible. See. So what is our matrix? Our matrix was A is equal to 1, 2, 3, and 8. Okay, so this is our given matrix. So how do we find the null space of this matrix? So we first bring this matrix to its row echelon form. So for doing so, if you look at the pivot element, so this is our pivot element here. So it stays still. So for second row, it is given by R2 minus 3 times R1. So what we will get 1, 2. So 3 minus 3, you will get a 0 here. And 8 minus 3, 2 is 6. So 8 minus 6, you will get 2 here. So if you look at this matrix, so this matrix cannot be reduced further. So you will get 2 pivot elements. So pivot 1 and pivot 2. So this matrix A has 2 pivots. Therefore, this rank is 2. So if you have the rank as 2, what happens here? When you solve this AX equal to 0 to find the null space, your rank is 2, which means there are no free variables. Only pivot variables are there. So therefore, the only solution for X is the 0 vector. So only when this X is equal to 0 and 0, you will get a 0 output here. So this matrix is an invertible matrix. Since its determinant is also not equal to 0, and also it null space contains only the 0 vector. So this null of A is only the 0 vector. So now what I am going to do is, when I am going to form this A, so yes?
Ma'am, there's a question. So
yeah.
You call it 0 vector or 0, 0? So that is where I got confused.
0 vector
so,
or 0, 0. Yeah, this one. Again,
or 0 and 0, 0 is correct, right? 0, 0 transport is also.
Yeah, 0, 0 transpose is also correct.
But and by definition we know that rank of 0, 0 dimension of 0 vector is 0. That's why the rank nullity theorem is satisfied.
Yeah.
Right? The rank of this matrix is 2. Nullity of the matrix is 0.
Yeah, nullity is 0. N minus R, which is equal to 0.
Okay, thank you.
Okay. 0, 0. So when you write this A, get B is A and 2A. So here I am having 1, 2, B8 and 2 times of A. Therefore, 2, 4, 6 and 8. So if you look at this matrix, you no need to solve here. Why? Because this matrix has only 2 columns. So once again, you will get only, if you want to solve this matrix, you will get only x1 and x2, which again boils down this equation. So whatever rows you add to this matrix, they do not matter because we have already reached our pivot element here. So 1, 2 and 0, 2. So the same pivots are going to come here, and there are no free variables. So therefore this null space of B is also equal to a 0. So this is also 0, 0, 0, 0. So we'll get 4, 0, 0. So since so this question I wanted to bring in because so for an invertible matrix, if you keep on adding rows beneath the 2 rows here, at that time your null space doesn't change. It is simply 0 here. We do not alter the matrix rank. So rank is still the same. It is equal to 2. So therefore your nullity is 2 minus 2, that is equal to 0. So the only 0 vector is the null space. So let us look at the third matrix here. So this for C matrix, what we are forming is, we are forming A and 2As in the horizontal manner. So 1, 2, 3, 8. And I'm adding 2A here. So 2, 4, 6, 18. So now what we have done, so we have increased the columns of this matrix C. So by doing so, the columns are changed, but keeping the row is same. So if you reduce, so this matrix is possible of having free elements, free variables. Why? Because of this same property, which is the null space. So if you will try to reduce this matrix, so when we reduce this matrix, the same we are going to do R2 minus 3 R1. So we will get 1, 2, 4. So 3 minus 3 is 0. So 8 minus 6 is 2. So 6 minus 6 is 0. So 18 minus 12, we will get so now if you look at this reduced form, so in this reduced form U, so you have the same, the rank is once again 2. So these two are pivot elements, but what you are having, so you are having 2 free variables here. So these two are free to choose. So when we have these free variables, we can have solutions for your null space. So how do you calculate this null space? For null space calculation, you want this, so let me hold on a bit. So these two are pivot columns and that is a free column. So now the null space are the vectors x which satisfies this condition ux equal to 0. So therefore 1, 2, 2, 4 and 0, 2, 0. So now what we are going to do, so we have to have this X matrix here. So we have 1, 2, 3, 4 number of columns. Therefore, X1, X2, X3 and X4. So now this would be equal to 0 and 0. So the pivot elements are 1 and 2. So the X1 and X2 are pivot variables and X3 and X4 are your free variables. So how do we choose this X3 and X4? We have this X3 and X4. Sorry, I made one else. Here it's 16, right? So that it is 8 times 2 is 16, right? So here also we will get a 4. So now we have to make this x3 and x4. So you can go for solving this equation with assuming the free variable as s and t, and then you can solve and then you can put values for s is equal to 1, t is equal to 0, or alternatively you can simply have it as x3 is equal to 1 and x4 is equal to 0. So at that time your equations are x1 plus 2x2 plus 2x3 plus 4x4. This is your first equation, that is equal to 0. And 2x2 plus 4x4, that is equal to 0 here. So by assuming this value, so I haven't checked this. So what will happen now? So we have this x4 as 0. So your x2 is simply is equal to 0. And substituting this x2 equal to 0 and x3 equal to 0, x4, x3 equal to 1, x4 equal to 0 in this equation. First equation, we will get x1 plus, so your x2 is 0 plus x3 is 1, so 2 plus your x4 is 0, so that is equal to 0. So therefore, your x1 is equal to minus 2. So this gives our first null space vector, which is minus 2, 0, 1 and 0. So in the similar way, we can substitute x3 equal to 0 and x4 equal to 1. So if you do so, the equations here you have to substitute x4 as 1. So 2x2 plus 4 is equal to 0. So now you will get x2 is equal to minus 2. And when you have this x2 equal to minus 2, x3, x4, you substitute in this first equation, you will get x1 plus 2 into minus 2, therefore you'll get minus 4 plus x3 is 0 here and x4 is 1, so therefore it is 4, so that is equal to 0. So therefore your x1 is equal to 0. So now we will get the second null space entry, which is 0, minus 2, 0 and 1. So therefore your null space of C is not a 0 vector. It is a span of these two vectors. Span of the first vector minus 2, 0, 1, 0 and 0, minus 2, 0 and 1. So I hope you are clear. So what happens? So in the question, the basic ideology is, so you can have an invertible matrix, so which will give you if you add the columns of the invertible matrix, it will lead to some solutions. But if you add the rows to an invertible matrix, it will lead to a unique solution, which is a 0.
Ma'am?
Yes.
Ma'am, how
Yeah.
did you, hello?
Yeah, go ahead.
How did you conclude that A is an invertible matrix?
So you can find that it is rank is equal to 2, right? Your dimension is 2 cross 2. Your rank is equal to 2. And also your determinant of this A is not equal to 0. No? So that is the condition we verify. No? Determinant of A is what? So 8 minus 6, that is equal to 2. So which is not equal to 0. So any such matrices which has determinant is not equal to 0. So those matrices can have inverse. No? So that's why we call it as an invertible matrix.
Ma'am, so
Yeah.
if given matrix is a full rank matrix,
Yes.
and there are no non-zero, I mean in its REF, there is all the rows are non-zero, then we
Yeah.
can say that it is invertible.
Yeah, we can say that it is invertible because there are no independent columns or dependent rows here. We can see there is no dependency between column 1 and column 2. They are independent, and also
So
they satisfy the condition. The determinant of the matrix is not equal to 0.
also, ma'am, in the B, when you see the B, so
Yeah.
we for the first two rows we got null space of B, and
Yes.
whatever the rows you add, it doesn't matter. But in
Yes.
here we have a null space of 0 0. Instead, there could be some other null space, right?
Here, no, the null space is unique. No, how? Because your null space is formed by the solutions of this equation. Bx is equal to 0. So these vectors form the null space. So what are the solutions which lead to a 0 vector? So only a 0 vector will lead to the 0 vector here.
Oh, okay, ma'am.
So that is
So,
why we say that it is a unique solution for this matrix. The null space.
so in B, if it is different, there could be different null
Yeah.
space.
See, what I'm telling is, if we have a condition like this, Ax equal to B. So this is a system of linear equations with Bx equal to B. So at this point, what happened? This is not equivalent to this one. No. So here Bx must be equal to 0. You should get only 0 here. So the only combination is a 0 vector.
Okay.
So that is why we say that this null space is a 0 vector. It's a span of 0 vector.
So, ma'am, we can say that for the first two matrices, they are
Yes.
both consistent and they have a trivial solution. So, is my statement correct?
And they are consistent, right?
Yes, and they have a trivial
Trivial
solution.
solution, yeah. The
Yes.
trivial solution, which is a 0 vector.
Right. That statement is correct, right?
Yeah,
Whatever.
that statement is correct.
Okay. No, I actually misinterpreted
Because
the construct of B and C. So I thought A and 2 as sort of, I mean, I took it as variables. So, I mean, they were the matrices by themselves. So that's
yeah.
why my answer came out wrong.
Okay. Because so only in the question, if you look at carefully, this B is made then A and the capital A, then the same notation they gave.
Yeah. I misunderstood that. So now I know. I mean, I
Okay.
knew how to solve, but I constructed.
Okay. So now you got the idea clear.
Yeah. Sure. Thank you.
Okay, thank you. So we shall move to the next question. So let me stop sharing and let's share that. So we have found this question. So next question. So it's simple. So what is the reduced row echelon form of the matrix A? So I'll give you 2 minutes to work out. find the reduced version form and you just pick your choices. Response. Okay, I've got 2 responses. Let us wait for 2 more minutes. So if any of the learners, if you have not joined to the session, you can type joinpd.com and then you can type in the code that is available on the screen and then you can join the session. If you have not joined it, you can join the session through joinpd.com and then you can type in the code and then you can also start answering. If you have not joined me, so you can please join the session. So go to joinpd.com and type in this code EAGKNB, then you can also join it. Here we have got 4 responses. Let us wait for one more response. So we have got 4 responses. I think this is a simple problem. So we shall look at your responses. Okay. So all of you have given the correct response. It is C. Yes, it is C. So I think we can just a simple workout can finish it quickly. Let me share my other screen. So this is our given matrix. So we have to reduce this to our reduced row echelon form. So the a good practice to form the four fundamental matrix spaces is to reduce it to its reduced row echelon form, because it gives you unique solution, and it is easy to identify the null space vectors easily from this reduced row form rather than your upper triangular matrix form. So how we have to reduce this, I hope you all knew because you all gave your correct answers. So the pivot entries should be 1, and below and above it should be 0. So already the second row there is a 0 here. So simply we have to change this R3, R3 minus R1, and R4 minus 2 R1. So which will give you 1, 0, minus 1, 1, 0, 1, 1, 1 here. So 1 minus 1, 0. So this is 1. So it is 1 and 1. And R4 minus 2 R1 will give you 0. So 3 and 3 here, and once again 3 here. So this can be further reduced in terms of the third row, because in our second row we got the pivot element here. So in first row already the pivot is 1 and beneath everything is 0. So for 1 the above element is already a 0, so no need to worry about that. So your R3 minus R2 will give you the 0 entry here, and R4 minus 3 times R. So this will simply lead us to 1, 0, minus 1, 1. So 0, 1, 1, 1. And in all the two rows we get a 0. So hopefully we have arrayed at our reduced row echelon form. So these are the pivot elements, and for the pivot elements the entries are 0 here. So this matrix is of significance because this matrix will give you unique solution for your null space and left null space vectors. Okay. So let us go to the question, return to our question. So this is a next question. Simple and straightforward. If a 7 by 9 matrix A has rank 5, so what are the dimensions of the 4 subspaces? So in this order, you have to choose your choices. Participants' mic is on mute. You can hear some background noises. Okay, I have one response. So I'll give it 2 more minutes because this is simple and easy, no? So you can directly answer. No need to solve it. This question is kept for understanding between if you have given with any sized matrix, how you are able to find the dimensions based on the given rank. So I have got 3 responses. Okay, so this is a simple question. So we can simply find the answer from here. So your dimension of this C of A simply is equal to your rank. So 5, comma, the dimension of row space is also equal to the rank. So 5, comma, 5. And your null space is the number of columns minus your rank. So 9 minus 5 is 4. And your left null space dimension is number of rows minus your rank. So 7 minus 5 is equal to 2. Okay, so all of you have got that right. So I hope everyone has clear understanding on all the dimensions of the subspaces. So let's move on to the next question. So here we are given for a matrix A of size m by n. So there are two statements. So the first statement is A and A transpose have the same number of pivots. And the second statement is A and A transpose have the same subspaces. Which is true and which is false. You have to identify. Okay. So I got two responses. I'll give some 2 more minutes. So I think others can kindly give you a response. Okay, 4 responses. Yeah. Well, let us wait for 1 more minute. Okay. So let us see your responses. Oh, so all of you have given option D, which is false and a false. Let me tell you the answer, but that is actually not the correct answer. The correct answer is option 1, which is the true and the false. So the first statement is true. A and A transpose have the same number of pivots. So imagine you have a matrix of size say m cross n. So what is the meaning of having same number of pivots? So same number of pivots means there are the number of linearly independent columns and also the number of linearly independent rows of a matrix are same. So that is why we have the same rank for the column space and the nulls and the row space. So in that sense, when you have the same number of linearly independent columns, the number of pivots are also same. So that is why this first statement is true. They have the same number of pivots. You can even see our examples in the tutorial, or if you have worked out, you can see the examples. So if you have a matrix and if you take a transpose of a matrix, you will definitely get the same number of pivots here. That is the reason for the first statement to be true. And for the second statement, for A and A transpose have the same subspaces? No, they do not have same subspaces. Why? Because when A and A transpose, the rows and columns are interchanged. At that time, if you find the column space of A, it will not equal to the column space of A transpose. So that's why they do not have same subspaces. And in every way, even if you calculate the null spaces, for null space of A and null space of A transpose is not going to be same. So that statement everyone have got it correctly as false. The reason for first statement is that is. So I hope you all agree with my answer. So let us move on to the next question. Hello, anyone want to talk?
Ma'am,
Yes.
so in a given M by N matrix, if the number of columns are greater than number of rows,
Yeah.
the maximum number of pivots that are possible is equal to number of rows, right? M.
Yes.
So it could be maximum, but it could also be less than that.
No, actually, the same matrix is transposed, you know. So we are transposing the same matrix. The matrix and its transpose. It
Okay,
has
ma'am.
the same columns and there is no change between the column or row. So if you in that case, if you consider, it will have the same number of pivots. The spaces are not same. They cannot have the same space, but the number of pivots, that is the, if you have 2 means, even if you change a 4 cross 2 matrix to a 2 cross 4 matrix, there also your rank can be 2. Did you get my point?
Yes, ma'am. Thank you.
So that's the condition. Because your first statement is true. You cannot have more number of pivots than the columns. But if the number of rows are greater, so at that time you will get the same number of pivots. The pivots will be equal to the column. So even if you change your rows to the columns, the numbers will be higher. So the values will be same. So for example, let me write, I'll give you an example that we just wrote here. See in this example, so here we saw this one example. No? So here the number of pivots is 2. So what will happen if this matrix is a transpose? If you look at here, so this C is a transpose of B. So this matrix size is 4 cross 2, but here it is 2 cross 4. So at this point, what happened? The same 2 pivots you obtain. So this is an example for that question. So even if you change the transpose of the matrix, the number of pivots is equal to the number of 2, which is the same. So I hope you understood the point. Okay. So now we shall go to the next question. So are you clear now? Do you have any
Yes, ma'am. I'm clear. Thank you.
Okay, thank you. So just a check. So shall we proceed? Or do you have anything confusing? Okay. I'm a little confused. Okay. Okay, then we shall proceed. So these are some basic concepts I want to stress. Okay, thank you for your participation. Let's go on to the next question. So here you have to find the rank of a 8 by 8 checkerboard matrix. So this is a checkerboard picture. So you can have 0 for black colored checks and 1 for the white colored check. So what will be the rank of this matrix? Give your response. You can take 2 more minutes to solve this. So far you get 2 responses. Okay, and wait for 2 more minutes. You form a matrix using this zeros and ones and you try to solve the rank. We have got 3 responses. Let me wait for 1 more minute. Solve. So the concept of rank, these are very useful for further applications when we go for image processing or signal processing. At that time, it will be useful to deploy this rank of a matrix to find the rank and trace. So these are some background fundamentals which you need to know when you go for higher concepts, higher level concepts. It will be useful for solving singular value decomposition. I mean, even in principal component analysis or even for any machine learning models, if you can work out, it will be useful when you want to reduce the features. In many places, we can apply this concept of rank for matrix. Okay, so we have got 5 responses. So let us see the answer. Why the 5th response is always pending? I hope an active participation from all of you. Okay. So I'll see the response. Okay, 2. Okay, so 4 of you have answered 2. Some have answered 4. Okay. So your answer is 2. So the rank of a matrix is 2. So solution is this. So when you write ones and zeros, it is alternatively ones and zeros for that checkerboard matrix. So at that time, what happens? This is the pivot entry, which is the first one here. So we just simply make everything to be equal to 0. So when you reduce this third row, it will be 0, 1, 0, 1, 0, 1, 0, 1. And if in the same manner, if you reduce the 5th row and the 7th row. Hello? Ah, yes. Yes, go ahead.
No, I'm sorry. Actually, sorry. That is a different thing. Sorry about that. Please go ahead.
Okay. Any confusion you want to share? Or, okay. Okay, so I hope everyone easily understood this step. So by doing so, you will get only the first 2 elements are pivot elements, and every row beneath this 2 rows will give you 0. So therefore, the rank of the matrix is simply equal to 2.
Ma'am, I did a more lazy method because row 2 is basically row 3 is basically exactly same as row 1. And row 4 is exactly same as row 2. So basically they're all linearly dependent. So only the first 2 rows are Li. So I just didn't even do the reduced form. I just did it as 2.
Okay, that's also a naive approach. That is what engineers think. We look at the solution easily even without solving. No, that is also a naive approach. You can easily look at the matrix and look at its nature, and you can also give the answer. This is a simple step-by-step procedure. Because in many matrices, there may be matrices which we cannot look and say that it is a rank 3 or rank 4. We need to reduce them. But these kind of simple matrices, your approach is also very good. Simply these two rows are linearly independent of each other, and others are the same. That's also a very good answer. So let's move on to the next question. So in this problem, you are given a matrix A. So can we express a vector B, which is equal to this 4, 3, 5 as a linear combination of the columns of matrix A? So we have to give a yes or no for this question. So for the both questions, I will ask you, how did you get the answer? If you based on your answers. I'll give 5 minutes. You can work it out. We have got 2 responses. We can take 2 more minutes to solve this. Okay. So if you need time, you can take time to solve. We got 2 responses. So are you solving or shall we get into the answers? Okay, I'll wait 1 more minute for you to give me answers. Okay, I got 3 responses. Show the response. So 3 of you have responded as no. Do anyone want to respond, or we can go for the solution? Okay. So I just want to ask you. So how did you solve this problem? Because I have responded as no. So can you tell me? Can anyone of you tell me why did you get this no as an answer?
Ma'am, actually I tried all possible combination of the columns.
Okay.
Hit and try method.
Okay.
I was trying a different approach, like AX is equal to B, and I was trying to see that whether we can get a solution. I mean, whether we get a dependency, but then in the reduced row echelon form, I think we what I found out from the pivot rows, I mean, none of the rows is zero or all zeros. So which possibly means that we cannot represent the B as a combination of the columns of A. I don't know whether I'm right. It's something I was trying.
Ma'am,
Yeah.
so AX is equal to B is something related to column space. So what I did is I found out the column space of A.
Okay.
So I found that the first two columns, span of first two columns is column space.
Yes.
So
Correct.
what I did is alpha times the first column plus beta
Yeah.
times the second column. And I
Should
try to
be.
see some values of alpha and beta. If you substitute, we'll get the B435.
Okay. But you didn't get
No.
But actually, the answer is yes. You can get this B as a linear combination of A. So your method is actually partially correct. So what we have to do is when we are given a vector B, and if you want to verify whether it is a linear combination of the columns of A, what we have to do is we have to augment this B vector with the A matrix, and then we have to try to reduce the solution, reduce it to its echelon form. So as you have already obtained this echelon form, see here, so whenever you reduce this matrix, you apply the same formula for the B vector also. So at this stage, what happens? So this second row is minus your first row. It will give you 0, 0, 0, 1, 1, 2, and 3 minus 4 also you have to do, which is a minus 1. And we have identified a second entry here. So now the third row is 2 minus 2 is 0, 3 minus 4 minus 1, 5 minus 6 it is minus 1, and 2 minus 4 minus 2, and 5 minus 4 it is 1. So after that you have to reduce this third row. So for the third row reduction, what we can simply, you can look at the second row and third row, they are negate of each other. So at that time you will get a 0 row at the bottom. So what have I done is I have augmented this B with A, and find, if you find here the B vector also, the last row which is equal to 0. So this leads to a solution. So this B can be represented as a linear combination of the columns of matrix A. So if you do not get a 0 in this B vector's position, at that time B cannot be represented as a linear combination of A. So this is the simplest way. How do you find? Because if you find a trial and error method, you cannot have a correct solution for the scalars, because there are infinite possible combinations. Any combination can lead to the zero vector here. But when you find without reducing this B vector, and when you find this column combinations also, at that time also you cannot go and check with multiple values for their scalars. So the easiest method is augmenting the vector with the matrix A and verifying the last row. If you get this last row, or even you can also get a previous row also a 0. It may be a rank 1 matrix also, but this is a rank 2 matrix. So you are when you are obtaining 0 here, it is a solution. So that is why this B can be represented as a linear combination of the columns of A.
So
So
I did a computation mistake. So that last -2 in your last row, I wrote it as +2, because conceptually I think I was right, because I was expecting that if all the row, if all the elements in the row, I mean, using the Gaussian elimination is 0, it would be dependent. Okay, I understood. That's okay.
Yeah, you're okay. So your approach is correct. Just,
yeah, I did a computation error. Yeah, so that -2 I had to be just +2. Okay, fine.
Okay. So the concept is clear, no?
Yes, absolutely.
Ma'am, why are we concluding that if the last row or any of the rows of all are 0, then how are we concluding?
How are we concluding this? Because see, for this vector B, what happens is this vector should be in a linear combination. Means this vector has to be in the column space of the matrix A. So when we identify the column space of the matrix A, we go for reaching this 0, all 0 vectors. No. So this B1, B2, and B3, B1 and B2 are dependent on B3. So this B3 is dependent on B1 and B2. If you get this formula, what happens? If you without this 4, 3, 5, you can write B1, B2, and B3. At that time, even B1 and B2 are, if it is equal to 0 in the sense, what happens? this is dependent on these two, right? So these two are independent and this is a dependent vector, this is dependent element. At that time, this B is a linear combination of the column vectors of this matrix A. It leads to a all zero vector here. If you do not get an all, you may get a all zero vector here, but you may not get a non-zero number here. At that time, B cannot be represented. So that is the insight here.
Ma'am, the
Yeah.
procedure I stated, so is
Yeah.
that correct or wrong, or I did any
Yeah.
mistake?
What you stated is you reduced the matrix A to its column space, no, and then you found the column space of A. That is also a naive approach. So you can find the column space of A, and then you can verify whether B is some linear combination of those two columns. That was your approach, right?
Yes, ma'am.
In doing so, what you are doing alpha times column 1 and beta times column 2, and you are verifying whether you are getting the vector B.
Yes, ma'am.
At that time, how many values can you substitute for this alpha and beta? That will be a time consuming process, right?
Yeah, it is hidden. I mean, trial and
Yeah, it's a
error.
trial and error run. Yeah. So that is why that approach also you have to manually, if you're calculating means, it will take many steps and many values you have to substitute, and then you have to find, because that solution is not solvable.
Yeah, yes, ma'am.
That solution is we cannot solve because alpha is same. So there are multiple values for this alpha, which is not a simple equation. We
Yeah.
have two unknowns with the three equations, right?
Yes, ma'am.
So that's why. If
You
are
get
having
different alphas and different betas. I tried to solve that
yeah.
also. I got different alphas but different betas with different combination of equations.
Yeah, because given this B, if you have a two row vector, so this matrix is a 3 by 4 matrix. So if you have, for example, a 2 cross 2 matrix, at that time you will get only two unknowns and two equations. So two unknowns and two equations is easy to solve. No, only it has unique solutions. You can get x1, for example, 5x plus 2y equal to 5, and 4x plus 3y equal to 3. At that time, you can solve for x and y. You can get the values. But what happens here? You have three unknowns and two unknowns and three equations. So that is difficult to solve practically. So that's why this is a simple method to reach the solution.
Understood, ma'am. Thank you.
Okay. Okay. Let's move on to the next question. So this is a question. So imagine it's a clear day and the sun is shining down upon the earth. Assume the vector v is equal to 5, 1 is the ground vector, and another vector u is 2, 1, 3. So it's a stick with the one endpoint on the ground and one endpoint in the air. So if the shadow of the stick is cast onto the ground, find the length of the shadow. You find the value and then you have to type your value. You can type your, if you get decimal places, you can type to 2 decimal places. If you get a float value, you can type in up to 2 decimal places. I'll give you 5 minutes to work it out, and then you give your answer, and we'll discuss about it. You've got 1 minute. So we have got 2 responses. I hope you are working. So let me wait for 1 more minute. I hope everyone would have related to the concept that is the underlining this question. Responses still. Anybody wants to work out? Okay, let's go on to see the answer. I think I would have worked out. So this question, we can see. Okay, so 2. So somewhere related to 2.5. Okay, so your answers are correct. It's 2.55 actually. So that is a question related to projections. So you have told that it is a sun is shining above and you are getting a shadow, which means I am projecting onto a ground vector V. So the vector is the U is there, your stick here. So this vector is projected onto the vector V. So this is ground vector and this is your stick vector. So at that time, how do you calculate this projections? Projections is U vector dot product of this UV by the length of the squared length of this V vector multiplied this V. So you will get projection value as vector as 2.5 and 0.5 here. Since it is simple, I have not worked it out. I hope everyone is clear with the projections. So the length of the shadow is the length of this projection vector, which is square root of 2.5 square plus 0.5 square, which is equal to 2.55. So no need to, I think, work on it. So shall we move ahead, or do you want this? Do you want to work it out? Do you want me to solve this problem? I hope everyone have got the answer correct. So I'll give you a question here. Before moving on to the next. Before moving on to the next question, I just want to ask you one question. So when will this projection equal to 0 vector? Can unmute and answer me. When will you get a 0 projection?
When it is orthogonal?
Yes, correct. So when your u vector is orthogonal with your v vector. So when it is 90 degrees with v vector, your projection is equal to 0. So that's very good understanding, because we may interpret when it is 0, if the two vectors are same, you might get a 0 projection. That is not correct. Even if the two vectors are same, we have their dot products. It is not equal to 0. So only when the dot product of any two vectors is equal to 0, you will get a 0 in the numerator, which will give you a 0 projection. Because when it is in 90 degrees, there is nothing to project. It is perpendicular to the vector. Okay. So let's move on to the next question. So these pairs of vectors are independent. So I have given you already, they are independent vectors. So your question is, are they orthogonal or orthonormal? So you type your choice for A and B. And you have 2 minutes to work out. Work it out and then give your answers. Okay, you got 3 responses. Okay. So let us take 1 more minute to answer. 3 of you have responded. Let's see your response. First one is orthogonal, second one is orthonormal. Orthogonal. Yeah, it is correct. Your first pair, these two vectors are orthogonal to each other because their dot product is equal to we'll get a 0, but they are not orthonormal. Why? Because they do not have unit length. But these two vectors, they are orthogonal also, and in addition to that, their length is equal to 1. So these two vectors, if you plot it, you will find this 0.4 comma minus 0.3 and the 0.6 comma minus 0.8. 0.8 are exactly at 90 degrees, so they are orthogonal to each other. But this cos theta, sin theta, it was difficult to plot it, so I guess gave the dot product. Their dot product is equal to 0, and even if their length, it will give you as square of cos theta and square of sin theta, which is equal to 1. Next question. So find the projection matrix for a vector A, and using that projection matrix, you have to obtain the projection of the B vector onto the A vector and compute the length of the error vector. You should find projection using the projection matrix formula. And you can type in your answer to 2 decimal places. To get a float value, you can type with 2 decimal places. So you compute your projection matrix for this vector, and using that projection matrix, you find the projection of the vector B onto this A vector. You will have the resultant vectors or certain matrix form which you get, and then using that you have to find the error vectors here. Still, I think we are calculating on it. Okay. We are starting to respond. Okay. So I think I have computed the error vector. So let us see your responses. Still more questions to solve. So let us see the response. Okay. So it is 0 to less than 1, more than 2.75, nearing 3. So your answer is actually 1.652. We shall see the solution. So first you will find the projection matrix. So this is your formula for your projection matrix. So projection matrix is A into A transpose by A transpose into A. So when you find A into A transpose, you will get a matrix that is here. So -1, 3, -1, -2, 1 multiplied by the same transpose of the matrix. So -1 into -1, 1, 3 into -1, -3, -2 into -1, 2. So 1 into -1, -1. So in a similar fashion, you get -3, 9, -6, 3 in the second row, and 2, -6, 4, -2 in the third row, and -1, 3, -2, 1 in the fourth row. So when you multiply this A transpose with A, what you'll get? Simply a square of the elements, which is equal to 15. So 1 square plus 3 square plus 2 square plus 1, which is equal to 15. And the projection matrix is 1 by 15 into this matrix. So that is your projection matrix. So after you obtain your projection matrix, how do you get the projection? You will left to multiply the matrix P with the B vector which you want to project onto this A vector. So the projection of B that is equal to 1, 0, 1, 1 onto A is simply left multiplying by the projection matrix. So that way you can get multiplied with the 1, 0, 1, 1. So this is a 4 cross 4 matrix multiplied by 4 cross 1. So your output is a 4 cross 1 vector. So one into, so this you omit all the second column and then simply you can add the other columns here, the value. So 1 plus 2 minus 1, that is 2. Minus 3 minus 6 plus 3, that is minus 6. 2 plus 4 minus 2, that is 4. Minus 1 minus 2 and 1 which is equal to minus 2. So this is your projection vector T. So once you obtain this projection vector, so how do you compute this error? So that error is how when you are projecting this vector B onto A, so what is the error? That is the perpendicular distance. So which is equivalent to simply B minus P. So that is your error. So your error is equal to B minus P. So which is your B vector is 1, 0, 1, 1 and we just found our projection vector. So when you subtract these two vectors, you will get this answer. Simply 1 by 15, you have it as a common value. So here 15 minus 2, 13. 0 minus of minus 6, that is 6. 15 minus 4, 11. 15 plus 2, 17. So once you obtain this error vector, this dividing, bring this 1 by 15 into this vector, you will get this form for the error vector. So have you achieved this error vector? Did everyone got this error vector or any different other value anyone obtained? You can share it with me. Can unmute and say, is this the same error vector that you got while computing? Or did you get any different vector? Can anyone answer?
Ma'am,
Yeah.
I took the error to be P minus B instead of B minus P.
Oh, you just reversed it. But even at that, even if you take P minus B, when you are doing a square root value, at that time, negate value will be given now. It will be cancelled.
Also, a mistake I did is
Yeah.
I did 1 minus 2 divided by 15 as E instead of 15 minus 2, that is 13 by 15 as one of the answer.
Okay. Because we have a denominator term here, no? But for fully it will be in decimal places, there are many chances of error. So an easy approach is taking 15 outside so that you bring in 50. This is so that's a simple approach. So I just followed that.
Okay, ma'am. Thank you.
Okay. So when you find the error vector, so now you have achieved our error vector. So this error vector length is simply a square root of individual element square. So this is your length. So the norm of E, which is equal to square root of this 0.866 square plus 0.4 square plus 0.733 square plus 1.133 square, which is equivalent to 1.652. So that is the error you get while projecting this B vector onto this A vector. So I hope it is clear to everyone. So while in attempting quiz, when you be provided with an online calculator, so at that time, make it simple for you not to use the calculator. By using your manual calculations, reach until this vector and use the calculator for the very necessary calculations. That will be easy for you to not make careless mistakes. Okay. So, so I hope the projection and projection matrices are clear. So the use of this projection matrix is you can when you have obtained a vector and its projection, you can find any projection of any other vector onto that vector. No need to compute all the steps. Simply you can go for multiplying the projection matrix with the vector that is wanted to be projected. Let us move on to the next question. So this is the question. So how can you represent these points in the 2D space? That is, you have given a XY plot which with data points, 5 data points, A, B, C, D, E. You consider this order for the data points. So the first point is A, and second is B, C, D, E. That's why I have given this ordinal numbering. So for these data points, how will you represent them in a 2D space? You have to give solve this problem in and give you a hint, that is you have to find the best fit line for this data points. And how will you represent a line? That you have to give me as answer. That is the parameters of the line. So this we have solved in our okay, yeah. I hope you might have judged it by now. So you have to find the representation for these points in the 2D space. And you have to enter your parameters for that. I hope the x-axis and y-axis are visible, or it is simply the values of a unit length 1, unit 1, 1, 2, 3, 4, 5, 6, 7, and for y it is 1, 2, 3, 4, and 5. That's it.
Excuse me, ma'am.
Yeah, the scale is same, 1, unit 1. So 1,
Ma'am, are we supposed to write the coordinate of these point? I cannot understand the question properly.
no, just I didn't say yeah, I have given you some set of points, okay? So how
Yes,
we
ma'am.
can represent it means, in this sense, you have to find a line for this best fitting line for its data
Okay.
points. So that is how we represent. It is not simply writing the coordinates. So you have to first find the coordinates of these points and a general solution to represent these points. Just you have to find a line which passes through these points, a linear line which passes through these points. And the method that we use to find the best fit line is the least squares method. So using that least squares method, you have to find the parameters for the line. What are the two parameters for the line? A line consists of a slope and the intercept. So that you comma slope comma intercept. That is your answer. That has to be your answer. You can take 5 minutes and then you get work out. I hope the question is clear. No? solving the problem of least squares method. So forming the coefficient matrix is actually the tricky part here. If you frame it in the wrong sense, then you won't reach the correct answer. So it is this question is like how do you get the vector x hat that is the parameters of the line. So in order to do so, we have to solve the least squares by using this least squares method. So that is the point here. You have to first get the coefficient matrix and the B vector, and using those two matrix and vector, you can solve for the x hat, which will give you the slope and intercept of the line. Yeah, it is a line fit. Once you identify that it is a line fit, I want you to find the parameters of that line. So I think, so this problem I will give you the solution so that the next one will be easier for you. So you have, so line fit, okay, you responded. So shall we see the solutions or you want time to work out? Can we see the solution?
Yes, ma'am.
Okay. Okay, so this is solved by the least squares method, right? So we have that data points plotted, and so we will get the x coordinates and y coordinates. So using that x coordinate, you find this coefficient matrix here. So these are the x values 1, 2, 3, 4, 5, and you just augment the vector with all ones. So this is for finding the line equation, which is equal to y is equal to mx plus c. So that is the line equation. So for attaining that line equation, you have m into x plus c. So imagine this column as mx and this column as c. So there is no multiplication factor for c. So it is simply c alone. So that is why we are appending one vector here. That is the reason for getting this one for this coefficient matrix. And transpose of this coefficient matrix is A transpose. And B is your y. So these y coordinates are put into the vector B. So this is your least square solution. A transpose A into x hat gives you A transpose into B. So when you solve this equation, you will get for x hat. So multiplying this A into A transpose, you will get A transpose into A. You will get this matrix 55, 15, 15 and 5. So you can try. So that is 1, 2. If you multiply this A transpose with A, you will get 1, 2, 3, 4, 5 multiplied with 1, 2, 3, 4, 5 as your first element. That is 55. And 1, 2, 3, 4, 5 multiplied with this second column. It will give you 15. And the second row of A transpose, which is multiplied with the first column of A, it will once again you will get 15. And the second row of A transpose multiplied with the second column of A, that is equal to 5. So this is equivalent to this A transpose into B. So here you have A transpose, here you have a B vector. So that will give you a vector of size 2 cross 1. So that is the first column, first row of A transpose and multiply with the B vector. So if you multiply the corresponding elements, you will get 49. And the second row of A transpose multiplied with the first, the vector with B, you will get 14. So now if you can, this is easily solvable. So you will get a system of equations with 55 eta prime hat plus 15 theta double prime hat is equal to 49, and another equation with 15 theta hat prime plus 5 theta hat double prime is equal to 14. So this you can easily solve by row operations. So that will give you 0.7 and 0.7. 0.7 for theta prime hat and 0.7 for theta double prime hat. You need to solve for this 0.7 because it is very straightforward. Once you achieve the only main thing in solving this least squares method is you have to form this augmented matrix, that is the coefficient matrix A, correctly. So what happens if you put this one before this column? At that time you will get the value for theta dash prime will represent your intercept and theta double prime will represent your slope. In this method, only you will get the first value as slope and the second value as your intercept. That is y is equal to mx plus c. So there is nothing wrong in augmenting this one previous to this matrix to this vector. But the only thing is you will get interchanged values for slope and column. So if you plot this line, you will get this value here. So you can see, so this is your best fit line. So this passes through these points. It cannot pass through all the points because no point is lying on this line. So it is simply a best fit line which gives you some minimum error. So this is how we represent a set of data points. So when you are given a set of data points, if you represent it like y is equal to 0.7x plus 0.7, so at that time what happens, even if I have a value for x is equal to 6, and if I ask you to find its y coordinate, you can easily find from this equation. That is 0.7 into 6 plus 0.7. So that will give you some point here. So that is a value for your unknown value of x. So that is the representation for any set of data points. I hope you understand why I framed the question like that. Because you have to represent all the points. Yeah, yes.
That theta prime
Yeah.
and theta double prime. So even the professor kind of just jumped into that. So
Yes.
does it mean the double prime and prime? Do they mean anything? Why don't we call them just theta 1, theta 2? Are they differential?
No, it's not like the differential parameters. Actually, sir, just to mention for the notation, he has mentioned it like prime and prime to differentiate those two parameters.
Okay.
That's why he has mentioned it like that.
So, and
earlier, okay, you go ahead. In lectures, he would have, this is your best solution. Before that, he would have written theta equal to theta and theta dash alone, hat and hat alone. So then since this is, we are predicting from the given equation. So that's why maybe he would have written as prime and double prime, just to differentiate the slope and the intercept value.
Okay, fine. That was confusing. So suppose we are doing this not as a line fit, but as a curve fit.
Okay.
So we are doing a quadratic equation or something.
Okay.
Would we have 3 different values for theta? Or I mean, probably it's the later lecture. I don't know whether I'm confusing myself.
Okay. No, I think so. If you want a quadratic line, it is ax square plus bx plus c. You will have 3 values. No. At that time, for a quadratic equation, you get a polynomial kind of curve instead of a straight line. So without a straight line, you will have a curve for the curve fitting. So
Okay.
at that time, yeah, you cannot go and just blindly append a 1 there because x is also x square, right?
So it's a more complicated situation, right? This won't scale for more than one, more than line.
This least square method is for a 2-dimensional coordinate system for finding the best fit line.
Okay, thank you.
For more than, for example, if you take, there are features, there are more than features. There we go for, there also we can go for linear regression. So there we use polynomial regression. When we have more number of features, we can go for polynomial regression and line fitting. So there you will study the parameters and the relation. How we are going to solve that one. Okay, so we'll study in our later part of MLT how when there is more than 2 dimensions. These are only 2 dimensions. So what will happen if you have more than 2 dimensions? How we can use this least square fitting? That also techniques. So we will study later. Okay.
Thank you, ma'am.
Okay. So based on this, the more question. So you have to consider 2 lines, a line with a 0 slope and y-intercept of 2.5, and another line, a line with 0 slope and a y-intercept of 3.5. So these are 2 lines. So which of these lines give the minimal error to fit the data points? So here you have the data points. You consider the order as A, B, C, D, E, F is here, F and G. You have to tell me, give the answer as which line gives you the minimal error to fit the data points. So how the line will be, or how the line equation, that you have to form the line equation, and based on the line equation you have to find the error to fit these data points. I will give you one hint. No need to solve the least square approach. It is simply you have to find the sum of the residuals. I hope you know the term residuals. So just find the sum of the residuals for every data point. That will give you the error value. And tell me which line gives you the minimal error. So the scale is simply 1, 2, 3, 4, 5, 6 in the x-axis and 1, 2, 3, 4, 5 in the y-axis. You know, these are some scattered points, but they form like an ellipse structure. So if you simply draw the line, you may not know which one gives you minimal error. So you can find the residuals, and the sum of the residuals will give you the error. So in our machine learning foundations course, we learned the line. In later courses, we will learn how to find the optimal line based on some optimization techniques that we will see in the later weeks. You have responded. Okay, let me wait for some 2 more minutes.
So, ma'am, so the difference
Yes.
between the errors is not actually very large, right? It's actually quite small. Small difference between the 2 lines in terms of error.
Yeah. You have to tell me, you don't need to calculate the difference between the error between the lines. You have to find the difference between the data points and the line. You have to find the error. How did you calculate the error?
I would look for lazy methods. I will tell you after we finish. I'll tell you the method I did.
Okay, okay. I can guess how you would have approached this problem. Okay, so we have 3 responses, so we will see your response. Okay, so I have chosen the line A. Okay. So that's the correct answer. Your line A will give you the minimal solution. So this is how we go for solving this problem. Okay. So we have the data points here. The y value is for every data point A, B, C, D, E, and F and G. You write the y in axis y coordinate values, and from the distance from the line 1, which is sorry. So distance from the line 1 means the line which is 2.5 here. So we will, I hope you have taken the value from 2 minus 2.5, and the square of the value is 0.25. And similarly, 2 minus 3.5, that square of the value is 2.25. So it is simply you just subtract the value of y from the line, because y is simply equal to 2.5. And here the y line is y is equal to 3.5. And sum of the distances is this error. So this error is 15.75 and this error is 19.75. So based on that, your minimum error is 15.75. So is this the answer? Did everyone get, or any of you got any other answer?
No, yes, ma'am. Got 4.
You got 4.
Yeah. But
Yeah.
my lazy method was I didn't even calculate them, because you could take off,
Okay.
0.5 square, 1.5
Yeah,
square.
yeah,
I
yeah.
cancel all of them.
Okay.
So only thing will be 2.25 and 6.25. That
Okay.
that difference will remain. So
Okay. So
Ma'am,
I found out the minimum error. Yeah, tell me.
instead of squaring, can we take absolute value of the distance? Like,
Yeah,
point?
that is also a Manhattan distance between 2 points. Any 2 points, we can take the Manhattan distance also. That is their absolute distance. Here I have calculated that Euclidean distance. Rather,
Okay,
we
ma'am.
can also go for taking the absolute distance.
Okay,
So,
ma'am. Thank you.
yeah, the distance formula, it doesn't matter when you go for finding this error. But it may, in later cases, when you deploy this machine learning models, at that time you will learn the selection of the distance parameter, the distance equation. How we can choose this? Either we have to go for this Euclidean distance, or we can is a simple absolute distance is enough. So those kind of terminologies you will study better when we go for machine learning models, because they play an important role in machine learning models.
Okay, ma'am. Thank you.
Okay. Okay, so that's all about the solve with the session. So did you find this session interesting and challenging? You can give your votes. Okay. So in between, okay. So it was actually, I hope it's not easy, not that much easy. So I try to figure out some part of difficulty to the questions based on yesterday's responses. I changed a few questions. So tomorrow we have an open session. So if you have any doubts related to any of the contents in week 1, week 2, week 3, you are welcome to the open session that is tomorrow. We will discuss on your specific doubts in many topics that will be dealt tomorrow in open session. Okay. So,
thank you.
participants, if you have any no more doubts, we can close the session.
Yeah, one question, not on this session, but
Okay.
would this be always on Friday 11 to 1?
Yes, it is. As per the calendar, we have given the timings.
No, it is only published only a week in advance. For example, next week we don't have it yet. At least we didn't have it. But I am a freelancer. I can block the time, so I can block 11 to 1 to be free.
Okay. This is the time for the sessions. this week, what is the time followed yesterday and today and tomorrow? The same timings will be followed for the upcoming weeks also. There will not be no more change. There will not be not any more changes in the timings. Same timings. Because as the live sessions for the other courses are also started, so now we will not be making any shuffling. So it is decided. You can have this time slot available. Make yourself available for this time slot every week. So thank you. Thank you all for your participation. I hope you're clear with the concepts of this week 3. So problem solving. So
Thank you, ma'am.
Okay. Thank you. Thank you all of you. Have a nice day. So we'll shall stop. We can stop the live streaming. So stop sharing. So Vignesh, are you there? The session is over. We can close the session. Vignesh, are you there? We can close the session.